Good day. Welcome back to our third lesson on grade 12 inverse functions. In lesson number 1, we discussed the inverse of the straight line. In lesson number 2, we discussed the inverse of the parabola. And now we're going to look at the inverse of the exponential. Let's see what this problem is about. In this example, they say that we need to determine the equation of the inverse of fx equal to 5 to the x. Now, you will recognize this fx equal to 5 to the x as an exponential function, and it's the increasing exponential function because of the fact that the base is greater than 1. So we're going to apply the same principle. We're going to swap x and y. So I'm going to say for f, we say y is equal to 5 to the x. And then for the inverse of f, and you can see I'm using the function notation now again, because the inverse of an exponential is also a function. And this will be x equal to 5 to the y. Now we need to find y, and to do so, we're going to use this definition right here at the top. You can see that this one says that if x is equal to a to the y, then y is equal to log x base a. So the inverse of the exponential function will give us a log function. So x equal to a to the y, then y is equal to log x base a. And in our example, a is 5. So you agree we can write down that y will then be equal to the log of x with a base of 5. And now we can write it in fx notation, and we can say the inverse of f is log x base 5. So we have the exponential function, we find the inverse, we get the logarithmic function. Let's look at the B part of this question, and you can see this question has got a little star next to it, and that means it's a little bit of a higher level question, still part of the syllabus, and it is because of this negative that is in the exponent. Now, it's not something you need to be too worried about if they give it to you like this. Let's apply the same way that we did in A. Let's do the same way for G. So I'm going to say that for G, y is equal to 3 to the minus x. And then when I go for the inverse of G, I'm going to say that x is equal to 3 to the negative y. Now we're going to use this definition again, like we did over here. And that will give us that negative y is equal to log x base 3. And we just want to get rid of that negative. So we say multiply both sides with negative 1. And we will get negative log x base 3. So now we can write this in fx notation, and we say that the inverse of g is equal to negative the log of x with a base of 3. So that's our first example. Let's move on to the next example. In example 6, they ask us to find the equation of the inverse, and as you can see, it's now a log function. So we've done in the previous example the inverse of the exponential, and that gave us a log function, and now we're going to find the inverse of the log function, and that will give us an exponential. So let's just do that. So for f, y is equal to the log of x with a base of 5, and then I say for the inverse, we will get that x is equal to the log of y with a base of 5. And now we need to use the definition again and we're going to use this one. You will remember that in example 5, we used this one. That is when we found the inverse of the exponential that gave us a log. Now we have a log function and the inverse will be exponential. So we can do that. We can say now that y is equal to 5 to the x, and therefore we can say that the inverse of f is 5 to the x. And with that, we are finished with number A. Let's look at number B. This is another log function, and you can see a little star next. We say be careful because of that negative x. But let's see what is going to happen. So I'm going to say that for g, y is equal to the log of minus x with a base of 3. And then for the inverse of g, x is equal to the log of negative y with a base of 3. And if we use that notation now again, that will give us the exponential function again. And we will then get that minus y is equal to, the base is 3 and the exponent is x. So now we can say that y is equal to negative 3 to the x. It's very important to take note that this negative does not belong to the 3 only, but the negative is outside 3 to the x. So we can now say that the inverse of g is minus 3 to the x. And with that, we are finished with example 6. So let us now look at example 7. In this question, the A part of this question, they ask us to determine the equation of the inverse of each of the following functions, and then we need to sketch the function and the inverse on the same set of axes, and we also need to show the line of symmetry, similar to what we did with the previous functions. So we will start with this one by finding the inverse of this exponential. So we will say that for f, y is equal to 2 to the x, and then the inverse will be x equal to 2 to the y. According to our log definition, we can now say that y is equal to log x base 2. And that means we can also write it in fx notation, and we can say that the inverse of f is the log of x with a base of 2. So there we have the equation now of the exponential function as well as the inverse, which is the logarithmic function. So now we're going to find 3 points and we're going to plot them. So first of all, we're going to look at fx equal to 2 to the x, and then we're going to look at the inverse equal to log x base 2. So I'm going to start with an x of minus 1, and if we substitute x with minus 1, you agree that y will be a half. Then we're going to substitute x with 0. Then y will be 1 because 2 to the 0 is 1. And then we substitute x with 1 and y will be 2. Once we've done that, it's quite easy to find the coordinates for the inverse because we just swap the x and y. So this will be a half and minus 1. This one will be 1 and 0. And this one will be 2 and 1. Now we need to plot these on our grid. we're going to plot these points. So let's start with the exponential function. And the first point we're going to plot is the point -1.5. So x is at -1. So let's take that as -1. That is 1 and 2. And that is 1, and this is 1/2. So the first point will be at -1.5. Then we're going to plot the point 0 and 1, which will be right there. And then we have 1 and 2. And that point will be over there. So you can see that this exponential graph will go right here. You can see it's an increasing function. And we did many of those in grade 11. So let's just quickly draw that graph. So you can see our exponential function. I sketched that using those 3 points, -1.5, 0, 1, and 1, 2. And this is the graph of f. So now we're going to plot the points for the inverse, the log graph, and that will be x equal to 1/2, which is right here, and y is -1. So that point right there at 1/2 and -1. Then we have another point, 1, 0, and then we have 2 and 1. And you can see that this graph will go right there. So let's just quickly draw that. So there you can see the inverse, or for that matter, the log graph. And we just need to name this graph as well, and that is the inverse of f. The last thing we need to do is to draw the line of symmetry, and that is the line y equal to x. So let's just draw that. And there you can see the line y equal to x, and I'm just going to put the equation on the line. And with that, we are finished with this A part. That was the exponential function, fx equal to 2 to the x, the inverse function of log x base 2, and we sketched both of them with the line of symmetry. Let's look at B. In this question, they ask us again that we need to find the inverse of this one, and you can see this is still an exponential function, but the base is now between 0 and 1, so that means this exponential function is decreasing. So let's just find the inverse first before we're going to sketch the function as well as the inverse as well as the line of symmetry. So we're going to say that for g, y is equal to 1/2 to the x, and then we say for the inverse, x is equal to 1/2 to the y. And that means we can now write it as y equal to, and this will be a log function again with a base of 1/2. And we can now say that the inverse of g is the function log x base 1/2. So now we're going to do the same as what we did in A. We're going to look at each one of the functions. So let's start off with gx, which is 1/2 to the x. And then we're also going to look at the inverse, which is the log of x base 1/2. And we're going to find 3 points. So let's start with g, and we go for x as -1, then x 0, and then x equal to 1. Now when x is -1, you hopefully will agree that y will be 2. When x is 0, any base to the exponent of 0 is always 1. And then when x is 1, y is 1/2. And now we can easily write down the 3 points for the inverse. We don't need to calculate them. and that will be 2 minus 1, 1, 0, a half, 1. And now we're going to plot these points, and we're going to draw these graphs, and after that we're going to draw the line of symmetry. So let's plot these points. If x is equal to minus 1, so let's put the minus 1 there, then y will be 2. So the y will be 2, minus 1 and 2. If x is 0, y will be 1. And if x is 1, y will be a half. And this point there is a half. And you can clearly see that this graph will go right here. And you can see it's a decreasing exponential. So let's just draw that graph. So there you can see the graph of gx equal to a half to the x. And I'm just going to name it. And this is, I'm just going to name it. And this is the graph of g. Let's now plot the 3 points for the inverse. And that is when x is 2, y will be minus 1. When x is 1, y will be 0. And when x is a half, y will be 1. Now, don't get confused with all these points. You can see that this graph is the decreasing logarithmic graph going right here. So let's just quickly draw that graph. So there you can see the decreasing logarithmic graph. That is the exponential, and this is the inverse of the exponential. And we just need to name it as well. And this is the inverse of g. The last thing we need to do is to draw the line of symmetry, and that is the line that will go right here. So it always intersect at 0, 0, and it also intersect where the two graphs intersect. So let's just draw that line of symmetry. So that is our line of symmetry, y equal to x, and we just put the name of that line on there. And with that, we are finished with number B. In number C, hx equal to log x base 3 is given to us. The question is the same as in A and B, that they want us to find the inverse of the function, and then they want us to sketch the function and the inverse as well as the line of symmetry. So let's start with the inverse of this logarithmic function. So we're going to say that for h, y is equal to log x base 3. And then for the inverse, we say that x is equal to the log of y with a base of 3. Now we need to write this in terms of y. So by using that log definition again, so y is equal to 3 to the x. We now have an exponential function. And we can now say that the inverse of h is the function 3 to the x. So we need to find 3 points again, but very important now, you can find the 3 points on h or on the inverse. Now, I will suggest that we use the inverse to find the 3 points because it's much easier to substitute the 3x values in here than into the logarithmic. And then to find the 3 points for the log graph, we will just interchange x and y. So let's start off with the inverse. So I'm going to start with the inverse function, which is the exponential. And then we're going to look at hx, which is log x with a base of 3. And I'm going to say again minus 1, 0, and 1. And we calculate the y values, and then we can find the points. So if x is minus 1, y is a third. When x is 0, y is 1. And when x is 1, y is equal to 3. And as you can see, very easy if you rather use the exponential function to find the points than the logarithmic. Now we're just going to swap them. So we're going to say it's a third and minus 1. It is 1, 0, and it is 3, 1. So let's now plot these 3 points. And I'm going to start with the points of the inverse function. And that is when x is minus 1, then y is a third. So it will be more or less there. That will be a third. And when x is 0, then y will be 1. So that point is 1. And when x is 1, then y will be 3 right here. So you can clearly see where this graph will go. And this is our exponential one, which is the inverse in this particular problem. And that graph will go right there. So let's just quickly draw that graph. So there you can see the graph of the inverse, that is the exponential function. So let's just name it, and this is the inverse of h. Let's now plot the 3 points for the log graph, and that will be when x is a third, y will be minus 1, so that is where minus 1 is. And then when x is 1, y is 0. And when x is 3, then y will be 1. And you can see that graph will go right here. So let's just draw that graph. And you can see that is the graph of h. That is the logarithmic graph. So let's just name it. This is h, and that one is the inverse of h. So now the last thing that we still need to do is to draw the line of symmetry, which is the line y equal to x, and which will go right here. So let us just draw that line. So there you can see the line y equal to x, and let us just put the name of this line right on it. So there it is. The inverse of the exponential, that will give you the logarithmic graph. And like this last example, the log graph is given to us, and we need to find the inverse, which is the exponential. Thank you.